What's going on, y'all? Welcome back to another episode of Papa Kirby Racing. Today what we're going to be doing is we're going to be looking at the Falcon911 crank, right? It's 45 stroke crank. So previously I had done some balancing to it based off of the old balancing stand that I had, and it turns out that stand may have been misleading me. So I'm going to be looking to see what the current balance factor is on this here. Now this crank is a lot heavier than normal, and I believe the webs I think were like 15 and a half or 15, I can't remember. We can measure that as well, but what I need to do here is I need to get the balance factor of this crank based off of what I did previously on this, right? So with these here, the way I have to do this is normally you would set the crank down, right, and then you would be able to move it, and it would normally go the rod normally goes up here, right? But being that this crank is still somewhat like in a factory setting, you could call it, it needs to be balanced and checked a little bit differently. So we're going to start with weighing the hung weight. We're going to get that down, and we're looking at 63 here. So take this off here. I'm going to turn this off, turn this back on. I like to do this a couple of times just to make sure. Alright, so we're going to do this again. Come weigh this out. 17.64. So now what we're going to do is we're going to weigh the con rod, right? So what I like to do when I weigh the con rod is I like to have it like this, right? So that it's in this position here. So we're going to do that here. We're going to get this clamp here to stop it from moving. We're going to see if we can set it evenly there, just like that. Okay, or we erase this here, get this set here, get that down, and let's see what we get. So initially here we're coming up with 27.2, 28.5. Let's go with that. 28.5. So you guys can see here, this is set here good, right? 28. And as I take my hands off of this thing here, it's gonna it's all set there perfectly. Here, as you see, and this is going down. 28.72, 28.7. We had it at 28.5. Still going down. I'm going to go in the middle and call it 28.7. Alright, so now we're going to weigh the piston, right, which will give us obviously our top end weight. So we have our ring, our wrist pin, our circlips in there, our bearing is in there, and then we have the piston itself, right? So let's go ahead and throw that on here. And we're getting a weight of 97.84. Alright guys, so now we're back here doing the balance calculator. So you guys can see here that I went ahead and I did, actually I already had these numbers in before, I didn't realize it, but I was just trying to weigh this again because I was just paranoid. But I got the top connector rod at 28.83, the hung weight at 17.64, the top end at 97.86. So doing all of that gives me I'm currently having a balance factor of 36.68. The reciprocating mass is 126.69, and as you guys know already, in case some of you that don't know, your reciprocating mass is your top end weight plus your connector rod weight, right? All that, those two together. So the current balance factor, obviously, when I did the calculator, is 36.68. I'm going to go ahead and want a 56% balance factor. So what I'm going to need to do is remove 24.48 grams. I'm going to use a 3/8 bit. That's the one I always use, 9.5 millimeters. So that's going to end up with 4 holes at 11 millimeters deep, right? So that'll give me the 56% balance factor that I want. So I'm going to go ahead and get that started. I'm going to get the drill press set up, and then we'll go ahead and get these 4 holes all drilled out, and then we'll come back and we'll remeasure the balance factor to make sure that we got the 56 that we're looking for. Okay, so we have the bottom end just put together, the motor seal on the case, right? There's no screws in yet. I don't have the seals on yet. but I have the bearings in place. One thing I did was put the spacer on, but I noticed that the piston is hitting the crank. I don't know if you guys can hear that. What I ended up doing was putting the jug on, right, with no ring or anything, and then putting it at top dead center. This does pop up a millimeter outside of the jug, so I do have a 1 millimeter pop-up head for it with a 7cc chamber for this one. But you'll see here that this line here is how much skirt is left when the piston is at TDC. So what I decided to do was, basically cut that in half. So I'm gonna go with this small line. So I'm gonna measure this here, and then I'm gonna go on the other side, right, and then draw the same amount on this side as well, so that we have an even amount removed. In the beginning, what I'm gonna do here is I'm gonna use my Dremel to cut some of this off, and then once I get closer to the black line, I'm gonna then go with sandpaper, and then just sand the rest of it down to have it be smooth. So I'll get that going, and then I'll come back. Alright guys, so we're back finishing up with the Falcon. So got the bottom end assembled. I just got to put the magnet stator and the small gear on. What I was doing right now was testing squish to get it to where I want. Took a lot of maneuvering, right? A lot of testing, trial and error. Oh, the one thing I want to show you guys too is I went ahead and did some piston clearing work, right? So you guys had seen that before. This had the lines because it was hitting the crank, and now it's clearing the crank perfectly, right? So we don't have any problems there with that. The other thing that we were getting a big squish, so we were using a 0.8 millimeter head gasket. This is also a pop-up head as well as it's a 1 millimeter pop-up head. So with the 0.8 gasket and the 1 millimeter, we were getting over 2 millimeters in squish. Then I ended up putting a 0.4 millimeter gasket on there, and it was giving me about like a 1.2, I think it was 1.4, somewhere in there, squish. So what I had to end up doing was I had to end up shaving the spacer down. So the spacer, when I initially measured it, I measured all the sides, right, to see like what it was. I had some sides measuring 1.8, 3 sides measured 1.8, 1 side measured 1.6. So I got this all down with a file and then sandpapered it down, all that, and I got it to a 1.4. So now we are at a 0.9 squish, like 0.8 and some change, like 0.9 squish basically. What's up, y'all? We're back. We just got done with finishing building the Falcon 911. Super excited to finally have this done. I had to build this in the middle of building other engines that I'm selling, plus the engines that I'm building for the races in October, right? But this is one that we're going to be debuting at the races. 48 bore, 45 stroke, 88 cc's. Let's go over this build, talk about everything that we did, to get to where we're at, right? So first things first, obviously it's an MZ Miami 45 stroke crank. As I mentioned, Falcon 911 48 millimeter bore, V-Force 3 reed with the 8 pedal reed valve. We have obviously we have an HD spring in here. I believe it's an RDM HD spring in here. We have an RDM clutch plate, hard pads, FKM seals. The crank is balanced and trued to 57%. We have a Fred head with a 7cc chamber. No gaskets on here, all modal seal. We have a 0.4 millimeter copper gasket, and the shim originally was 1.8 millimeters on 3 sides, by the way, and one side measured 1.6, right? So when I measured like this side, this side, this side, and then the other side, right, to get even measurements, it was 1.8, 1.8, 1.8, and then 1.6. So I took my file and I got this all 4 sides down to 1.4. Okay, and so with a 1.4 millimeter shim and a 0.4 millimeter copper head gasket, our squish is now at between 0.8 and 0.9. And obviously, we have the upgraded ignition system as well. on it. So we have the 450 millimeter ohm stator, as well as the updated magnet on there as well, right? So for those of you who are going to be at the races in October, we'll be having this there. The other thing too that I forgot to mention is this is also a 1 millimeter pop-up head, right? So even with this with the 1.4 millimeter shim, the crown of the piston was still popping up that millimeter. So with this 1 millimeter pop-up head and that 0.4 millimeter copper gasket, we're at a 0.8 squish. So this is it, y'all. This is it. Like, subscribe, comment. Thank y'all for watching. Appreciate the support.